Welcome back to part 2 of the missing bracket for the Cub Cadet lawnmower. In this video, I cover how we used oxy-fuel for heating and bending that threaded rod you see right there. And I'll go over the entire setup from start to finish.
Oxyacetylene today, arguably the most portable process because it doesn't require electricity. All you got to have are your tanks charged with gas. It's also probably the most dangerous tool in the shop, especially if you don't know what you're doing. And I'm not talking just about the acetylene here. I'm talking about working with oxygen. If you've ever looked at an oxygen regulator, it specifically says use no oil. And that's because although oxygen is not a fuel gas and it doesn't burn itself, it can cause combustion of hydrocarbons like grease and oil when they're under pressure. And I've seen it happen, and it's scary as hell. Now, oxyacetylene does have its limitations. That's why other arc welding processes were invented, right? But at the same time, oxyacetylene is extremely versatile. So it can be used for heating, bending, right? We've all heard of the liquid wrench. You heat things up to red hot and they like to move around a little bit more. You can also use it for soldering and brazing and even welding, although it's slower than most of the modern processes. Did you know that oxyacetylene can actually weld aluminum and people still do it today? Let's talk quick about the equipment that we're using. Okay, we've got two different cylinders here. This one, the acetylene cylinder, is what they call a low pressure cylinder. On the other hand, we switch over to oxygen. Oxygen is a high pressure tank typically delivered around 2200 PSI. So this thing was basically made out of one blank of steel, typically a chrome steel, and then it's stretched and formed into shape. There are no welded components on a high pressure cylinder. Couple of things. With a low pressure cylinder, especially one storing a fuel gas, we're only going to crack that open enough to make the regulators come up and to make sure that we're getting full pressure on the regulator. We don't open them all the way because in case of a fire, the best way to put out a fire with an oxyacetylene or any oxy-fuel flame is to shut off the fuel source. So if you notice a flame where it shouldn't be, turn off the gas. That puts it out right away. Okay, just be prepared that if you're having a backfire where the fire is going back up the torch, this could be hot, so use your gloves, all right? But that is the quickest way to extinguish a flame. On the other hand, an oxygen cylinder is a high pressure cylinder, and there's packing inside this valve. It's also a double seating valve, so it seats all the way at the bottom, and when you open it all the way to the top, it seats again at the top. And what that does is it takes that internal pressure off the packing so it doesn't leak around the nut. So it does matter when you're running a high pressure cylinder, whether it be oxygen, C25, argon, or any other argon mix. When you see this high pressure cylinder, that valve is meant to be run fully open. So we're going to be using this for heating and bending, not for welding, not for cutting, which of course oxyacetylene is also very capable of doing. It can cut steel, it can cut iron-based materials, but it's not going to cut stainless and it's not going to cut aluminum. So that in that case, if you're working with those metals, that's why we jump up to plasma if that's your goal. Okay, so let's walk through the process. A couple of things you want to do is make sure that you're always maintaining safety and proper usage of oxyacetylene equipment, all right, including the tanks, the regulators, the adjustment, and all your valves that you're working with, okay? All right, let's start with the oxygen cylinder. One thing that you're gonna notice is the regulator and the gauges are pointed slightly down. And there's a reason for that. It's not just because I'm seeing things a little crooked. It's because if these things are ever gonna fail when we open this valve, they're gonna fail straight out, okay? So if we have that pointed straight or up in the air, that could become a projectile. When we point these down at the ground, we ensure safety of others around us, because if this was to fail, it's going to point down at the floor. And that is definitely a reason why we do this. The next thing that you're going to look for is that this thing was stored correctly, right? So we see zero pressure on the primary gauge, zero pressure on the outlet gauge, and our T-handle is completely backed out, so there is no pressure on that diaphragm. Again, if we leave pressure on the diaphragm, when you open this valve and it gets hit with high pressure, that could come on out and cause that to fail, and again, this is going to become a projectile. We do not want that. So what we're going to do is we're going to stand off to the side, and we're going to slowly crack this valve. I say slowly, I got to get her to move. And we're going to see the primary pressure gauge come up to pressure. So we've got about 2,000 PSI, just under 2,000 PSI in this tank. And again, we're going to keep opening it till it's fully open so that that valve is seated all the way at the top. Okay, now to dial in my pressure, what I typically want to do is turn this T-handle clockwise, and we're going to dial this in. This says 40 PSI, and we don't need to be that high unless we're cutting. So I'm going to start out a little bit lower, right down around half of about 20 PSI, which is plenty of oxygen running an equal pressure torch, because we technically only need about 10 and 10 for this setup, according to the manufacturer recommendations. Now, our oxygen cylinder is fully pressurized and ready to go. Now let's take a look at acetylene. Remember, acetylene is filled with liquid, and the gas is dissolved in that liquid, kind of like a soda pop. Because if we put that gas under pressure, right, 29.4, it becomes completely unstable and will spontaneously decompose, which means it can ignite and blow up. So that 15 PSI, the red line that we see on our gauge, is a factor of safety of 2, so that we don't operate anywhere near 29.4 PSI. That's actually the point at which acetylene becomes unstable. However, most people would say 15 PSI is the max you would run it at, but that is not the point it becomes unstable. That's the point we run it because of the factor of safety. Okay, again, this is a low pressure cylinder, so we don't need to open the valve all the way. I see in here, I've got 0 PSI on my primary gauge, 0 PSI on my secondary gauge, and my T-handle is backed out. So we're going to open this up just until we see that move. Good to go. 1 to 2 turns, right? Then it's easy to turn off in case of a fire. Now we're going to go ahead and we're going to dial in our pressure, and we need about 10 PSI. Dial it right up to 10. Now, one thing you can do, and I don't know that it makes all that much difference, is you can open up that fuel gas and make sure that it stays at 10 PSI while we're flowing gas. At the same time, we can do that with our oxygen. Then we know we've got a good gas supply and we're ready to move forward. All right, now let's light the flame. So we're going to crack the fuel gas here. It's marked with an F. Crack it open until we hear gas flowing. Then we're going to use our flint striker, and we're going to light that up. Okay, you can see the soot coming off of there. I know that I need to turn that up until the gas stops sooting, until we have about 1 inch of concentric flame coming right out the end of that nozzle. And now what I'm going to slowly do is I'm going to slowly add oxygen to increase the combustion rate to make sure we're burning all the fuel gas. All right, so this is what they call a carburizing flame. What we want is a neutral flame. So we're going to dial that inside feather right down to where we only have those cones in a light blue shade. If we go too much, they'll turn purple, and we know we have an oxidizing flame where we have too much oxygen. All right, now extinguishing the flame, I turn off the oxygen first, and then I turn off the acetylene. You can do it in the opposite direction, and some torch manufacturers actually used to recommend that you turned off the gas first and then the oxygen, but it makes a big snap, crackle, and a pop. So I think most people have now changed that process or that procedure to being turn off the oxygen first and then turn off the fuel gas, right? So, but either way works, so long as we're turning the gases off, right? Always best to follow manufacturer recommendations. So let me show you the project that we're going to do. I've got some threaded rod here, and what we need to do is bend this so that we end up with a minimum of 13 inches, then 9 inches, and then another 13 inches on the outside. So what I'm going to do is we're going to use our handy dandy table, and I'm going to pop it right in like that, okay? And then I'm going to slide a piece of pipe over the end, and once we heat this up to the red hot, we're going to use that pipe and this bar to pull it right over to 90 degrees where we need it. All right? Let's see if that works. All right, let's light that torch again. We're going to open our acetylene. We're going to light it up. Make sure that that flame is not leaving the end of the tip. get about 1 inch of concentric flame. Then we're going to dial in a neutral flame. All right. Now, we're going to heat this up to the red hot condition. And we're going to drop it down to right there. I'm going to drop my torch off to the side, out of the way. We're going to grab it and bend it right over. Just like that. Now we've got a 90-degree bend. We'll let that cool. We're good to go. Okay, now we got to do the same thing up here. And I'm wearing my respirator right now because this is galvanized, and although I'm not burning a shit ton of it off of there, chances are I could be inhaling some zinc, and we don't want to do that. So we'll go ahead and wear my respirator and make sure to protect my lungs while I'm doing this job. I'm going to rock this up here and bend it right around at 90 degrees the same way we did before. Actually, okay, so real simple setup, easy to use, doesn't require any power. A lot of people would just close the valves, coil this back up, shove it in the corner, but that's going to leave pressure on the diaphragm and pressure on these gauges, and that is not the proper way to store oxyacetylene equipment. So here's what we're going to do. Right now, everything is fully charged. The first thing we do when we're shutting down the system is you turn off the sources. Whether you're working on a manifold or with cylinders, turn off the source first. So let's turn off our oxygen, right? Arguably the most dangerous gas we'll work with because it's an accelerant, right? And it can cause spontaneous combustion of hydrocarbons. Then we're going to turn off our acetylene. So now everything is closed off. Now the next thing you might do is to back out the T-handles and relieve pressure, but that's going to leave pressure behind the diaphragm that you don't want to do, right? It puts extra stress and strain on the diaphragm. It could cause it to fail, and when we hit this with pressure the next time, there's already going to be some gas there. So best way to do it now is we drain it out. Now, I drain acetylene first, and here's why. If I keep positive pressure in my oxygen line, there's no way that acetylene is going to find its way into my oxygen line, which is bad, right? This I learned from scuba diving. Never drain your tanks all the way. So if we get rid of the acetylene first and get it out of there, then we can drain the oxygen and not worry about any cross-contamination. And that's just my theory. Take it for what you will. Okay? So we're going to go ahead and drain the fuel gas. Again, we have not backed out the T-handles. All we're going to do is open this up until both gauges read 0. When both gauges are at 0, we know we're good. So then we can back out the T-handle, right, until it's loose, so there's no pressure on the diaphragm. And then, because I could be coming to your booth next and doing a demo, turn off the fuel gas, right? That way, when we go to turn this back on, we don't get distracted or called away from our job and leave the acetylene tank on while the valve is open, purging the whole area with acetylene. Call me crazy, but I don't think that's a good thing. All right, so our acetylene is drained down. I've reclosed that valve again to stop mixing that might happen between the pressurized oxygen and the unpressurized fuel gas. Again, that's a no-no. The mixing valve is in here for a reason. It's supposed to mix in a certain area. If it doesn't mix in that area and it mixes in the tube, you could have a problem on your hands. So now we'll go ahead and open this up, and then all I got to do is pull the trigger, and my oxygen drains completely down on both sides of the valve. My valve is off. Now I can back out that T-handle to a safe condition, and I'm not going to put anybody in harm's way when they come to be the next one to use this equipment. Again, let's turn that valve all the way off, and then we can coil it up and stick it in the corner for storage. It's perfectly safe. It's perfectly ready to use the next time we need it.
I'm Brent Williams, and that wraps up our demonstration of heating and bending. In this video, we took a look at how to properly charge and discharge an oxyacetylene system. We also looked at how to use a flame to heat our material to the red hot condition so that we could bend it easily. And we discussed various applications, including the need to protect yourself and use a respirator when you're working with coated materials, especially galvanized, that could have short and long-term health implications. Now, I was using a Miller-Smith setup for this, and the manufacturer recommends 10 psi of oxygen and 10 psi of acetylene to operate their equal pressure torch for things like welding, brazing, soldering, and heating. They also instruct to increase the oxygen to say 35 to 40 psi for cutting applications. So we ran this at 10 psi of acetylene and about 20 psi of oxygen, just to make sure that we had enough. As long as we don't go over or under the limit, we were in good shape. But be sure to check your operator's manual and check with your manufacturer, because each brand could be slightly unique, although the setup and cleanup of any system is relatively similar, except for the specific details and the nitty-gritty settings. For example, my first oxyacetylene setup was a Victor system. And for years, Victor recommended 7 psi and 7 psi to operate their equal pressure torch, right? Obviously with more oxygen pressure there in the case of cutting. But when I switched over to the Smith, I checked in the owner's manual and found out they had slightly different recommendations. And remember, acetylene is a fuel gas that becomes unstable under pressure, so we never want to use it above 15 psi. That gives us a factor of safety of 2 because it actually becomes unstable at 29.4 psi. But we don't want to run the pressure anywhere near that. Oxygen, on the other hand, is a high pressure cylinder. It's not a fuel gas and it won't burn on its own, but mixed with a fuel gas, it becomes an accelerant, where it increases the combustion rate and increases the flame temperature. And remember, fully open on a high pressure cylinder like oxygen, and only 1 to 2 turns open on the valve for a fuel gas like acetylene. As always, thanks for watching. If you found this video informative, educational, or useful, be sure to give us a like and subscribe to catch any future videos. And until next time, keep your hood down, don't stare at the bright light.